Saxon's Calculus, Lesson 39. They title it Graphs of Rational Functions for the second time they're discussed, and then a special limit. However, Part A is about poles and zeros. Then Part B is the rational functions, and then in Part C, they do their special limit. So poles and zeros you should recognize from trig class. And a zero is, of course, an answer to the problem, or where you would create a zero on the X line. And a pole is going to be where you cannot, whatever creates a zero in the denominator, you cannot graph, therefore you are creating an asymptote there. So basically in Part A, they review those terms, and then they give you in Part B the specifics. And I think the example, or do I need to pull the one from here? Before I find their example, one of their darkened sentences on page 200 reminds you, since a rational function is composed of unique non-repeating linear factors that change the sign at every zero of the numerator and the denominator, the graph must cross the x-axis where you have the zeros. So when you're doing your graph, if you aren't creating an asymptote, if it's a zero place, your graph has to be crossing through the x-axis at that spot. That's what their wordiness means. And it jumps across the x-axis at every pole because you've created an asymptote. It's skewing you is what that means. Now, they show you a graph on page 201. Here's your example on page 202. Graph f of x equals negative, don't lose that's there in this big, huge, long, x with x minus 7 is the top, and then x plus 5, x plus 2, x minus 2, and x minus 5. Finally, all right, so it says first, figure out your zeros and your poles. Yes. So the numerator, this would be, if I am setting these equal to 0, this would be at 0. I'm going to have a dot that's crossing the x-axis. This one would cross at 7. 1, 2, 3, 4, 5, 6, 7. So there are my two dots where I cross the x-axis. Everywhere I create a number down here that gives me a 0, those are asymptotes because I can't have zeros in the denominator. So this one would be at negative 5, 1, 2, 3, 4, 5, and an asymptote. At negative 2, asymptote. At positive 2, and at positive 5. 1, 2, 3, 4, 5 here. So that's the first part of my graph. Then, oh, and I do have to look for holes. Holes would be any time I have, where I drew an asymptote line, I might not have been supposed to have drawn it there, it would be creating a hole. But let's see, I don't have the same x or the x minus 7. But if that had been true, if I'd had the same thing top and bottom, we would have just skipped drawing an asymptote line there and waited until we created what the graph should be, and then put a circle, a hole in the spot where they would have overlapped. Okay, so now that we're here, we can, and it's negative. That tells me that overall, every part of my graph is decreasing or in the negatives. For you, at the beginning of this process, I would still recommend plugging in points and seeing what the graph gives you. So I would plug in negative 1, 2, 3, 4, 5, negative 6, and see that when I do negative 6 here, and just punch it on my calculator until I get an answer. And what I'm going to discover is that I get a very small negative number. So at negative 6, I've got a very tight little negative. So that tells me I'm bounding to the x-axis and this asymptote in the lower negatives. When I plug in 1, 2, let's say negative 3, I discover that I get a positive, very tight little fraction. So I'm opening upward here in the positives and creating a parabola. Here, I know I have to cross it, and since I know that I am decreasing because it's negative, then I'm going to asymptote cross through and go to the other asymptote. For this one then, if I plug in 1, 2, 3, let's say, I'm going to discover that I get a negative in here. And since there's multiple spaces here, this is going to be a parabola, but this is definitely not the vertex. It's probably mirror imaging here with the 4, and you can test that if you so desire. So that tells me the vertex is probably somewhere in there, and then I can graph my curve. And then finally, I know that in this section, I have to cross, and I'm decreasing, so I'm coming downward and crossing over this one and getting down into the negatives. Now they said begin here, but that's neither here nor there. Example 2, sketch y equals x plus 5, x minus 3, x minus 1 over x minus 4, x plus 2, x plus 4, and x minus 1. Now this x minus 1 here at the end is going to create the hole we just talked about. The graph at -5, 1, 2, 3, 4, 5, I will have a dot that I will have to cross over. At +3, I will have a dot. And then at this -1, I know I'm going to have a hole, so I'm just going to ignore that for the moment. So I realize that 1 is a place where I need to watch. Now, asymptotes at 4, at -2, at -4, and then that 1, we already know we have a problem. So it's overall positive, so all of my graphs should be climbing. In this section, I know I have to cross, and since I'm climbing, I'm going to do this and cross. I also know that the x-axis bounds me, and so it's going to bounce and then come back closer to that, which is kind of weird, but so be it. Then I would plug in -1, 2, -3 and see what kind of an answer it gives me. Well, it gives me a negative of some sort. It's not super tight in there, but it's in here approximately. So then this parabola is opening downward. Now I get to this section with my 1, and I realize I have to be kind of careful because I'm going to create a hole. But the asymptote, and I'm climbing, so I want to be coming from the lower, crossing through this, and then bounding over here. Now, if you want to plug in like a 0 and see what answer it gives you so you kind of feel how fast that thing is going to swoop, you can do that. I'm just kind of estimating it here. And then where I have a 1, I make sure I put a hole and I erase the line because that was my problem spot. And then I need to get what's happening over here. So I might plug in 1, 2, 3, 4, 5 and see what it gives me. And it's a fairly large number. So it's up here. So now I'm okay. I'm up here in the positive section. I'm bounded by this, and I'm going to be bounded by the x-axis again. Part C, the special limit, they are trying to get you to figure out the ones that we just memorized for sine going to cosine, cosine going to negative sine, and e to the x remaining e to the x. So what you should be seeing them do there is plug those into your basic derivative formula, which is your x plus the change in x minus the f of x, oh, sorry, I forgot the f there, all over the change in x, but then we had learned that we're going to change those to h's. So if you wish to walk yourself through to see why they get what they get for those, or you can take my word for the memorization of those, that's fine either way. But that's what they're doing there in C, is they're trying to prove to you by plugging in. And so for just to help, when they're plugging in the sign, they're also assuming that it is pi over 2 as like a memorized radian that you should be using for that. And then solving down, and that's how they get to the cosine. Same thing with the negative sign, although I'm not sure they showed you that one. And definitely the e to the x, they work through and show you.